Hello, everyone. I'm Rami. He's Dirk. We're going to be talking about compiling open source applications for PCF with Docker. So to give you guys some context on what we had to do, we were pairing a few months back and working on a proof of concept for an antivirus application, specifically a service. It was supposed to check uploaded files and say, hey, does this have a virus or not? It's mostly Word docs, PDFs uploaded by our clients in these like real estate applications such as CondoSafe, and determine whether or not it's got a virus or not, and allow them to upload the document. So what we started doing was we said, hey, what do we need?
Oh, okay.
Go ahead.
I thought you were going to say everything. What we don't need actually is an FTP, some kind of FTP server with an antivirus program on it. We don't want we want to expose a nicer API. What we want is an actual service, and basically you just contact that service with a standard HTTP thing. You throw a document as an attachment in it, and it tells you yes or no. This is a good document, or this is a dangerous document. So the service will receive documents in an HTTP call, and then it passes on to its internal antivirus service. We didn't want to reinvent the antivirus service. We want to use the canned one, of course.
Right. So we did some research and we said, what antivirus solutions are out there that we could use? We came across ClamAV. It's open source, trusted by many. It's not bleeding edge, but given that we're just testing like Word docs and PDFs type thing, there isn't really a need for the latest bleeding edge antivirus solution. Plus we were in POC mode, so we were looking for something that was free. Yes.
Okay. The problem was that PCF, and we wanted to go to PCF in the end because everything for CoreLogic runs on PCF, and ClamAV don't play nice. ClamAV was really made for desktop environment. It has a server mode, but that basically means you have a little server running on your desktop and you have a client app. It's more that kind of separation than an actual server to be on the cloud. The other problem was that there are actually binaries for, of course, for ClamAV, and they're for Mac and Windows, and those things. There's no binary that you can run right away on PCF. It's built in C, and there's also no C build pack, so compiling it from sources was also not an option. So we're stuck. We have this nice piece of software, but how do we deploy it to PCF?
So we asked the question, how do we compile something for PCF outside of PCF? And we went to the Cloud Foundry team, specifically Evan. Thank you for your help on this, Evan. And he said, hey, there's this Docker image available that you could use that is effectively the Cloud Foundry file system. You could run your compilation inside of this Docker image and then get something that you could deploy out to a PCF container. And we said, okay, cool. Now we have a plan. We're going to pull down this CF Linux FS2 Docker image, download the ClamAV sources, compile the thing. That turned out to take about a half an hour, so we grabbed a beer in the meantime. And then we grabbed the resulting binary, stored it somewhere, and were able to use that, and we deployed. Go ahead.
So wait, why don't we just deploy this whole Docker container to PCF? Was of course a question that came up, and in fact we even thought about that ourselves, because PCF does allow you to deploy Docker natively on PCF. The problem is that at that point the CoreLogic runs its own PCF environment, and they didn't actually offer that option yet. It was simply switched off, but it would be work to have it switched on. But the more important part is that if you do that, you lose part of PCF strength. So one of the nice things that PCF does is it updates kernel versions for you, it updates security software for you, and it updates build packs for you, and all you have to do is recompile. If you deploy your own Docker image, you basically have your own VM running, and you're responsible for everything inside that Docker image. If a new version of Linux comes out, you better update or you get outdated. So we didn't actually want to just deploy the Docker image to the cloud. The other thing is also interesting to know, there's a nice read there by the HFT guy in 2016 about all the troubles they had just running Docker in production. It's a very interesting read. It's very opinionated. I just certainly disagree with some of it, but it's interesting to read that it's, as the PCF guys always say, just having a container doesn't mean that you now can deploy in the cloud. You need a lot more, and that post nicely details that.
So again, our plan is you have a client application. They're going to stream over a file to our antivirus service, which is running in a PCF container. That antivirus service is going to leverage ClamAV, which is an antivirus solution, and it's going to scan the file through ClamAV and tell you if it's good or not. So this diagram shows the file coming in from the client application, going to our service, down to ClamAV, and back up the other way.
And those squares on the bottom were thumbs up at one point, but I see this computer doesn't display those.
Right.
Oh well. So we built the Dockerfile.
So here's our Dockerfile. So there's a lot of text here. So what we did was, obviously at the start, pulling down the CF Linux FS2. The from command there means grab this existing Docker image and leverage it, basically.
I'll quickly go to the next slide.
Yeah.
So here's from. It pulls an existing image from hubdocker.com. So you don't have to do anything on Docker. You just write from, and the first time you run it, it will do some churning. And next time we'll have it cached, so it'll be much faster.
Exactly. Then usually you have your run command. So in our run command, now remember in Cloud Foundry, your application is deployed under /home/vcap/app. So we wanted to make sure that we had all the proper directories for ClamAV in our case to run correctly. So everything has home, vcap, app, and then we have ClamAV and all of ClamAV's directories. So we create all these directories for ClamAV. We create a shared directory, which is going to be a mount point. And then we go ahead and say, go and download the sources and untar them. And if you notice, the run command is one giant command that spans multiple lines. And the reason for that is, after each run command, Docker will actually store an image of your status.
So originally we had separate run commands, which means you have a whole bunch more images, which basically makes everything a little slower. This is a more like optimized way of building a Docker command.
So then we obviously changed directories into where we just untarred everything, and that's just what that workdir is. And then we run the command to go and compile everything. So it's your typical configure, make, and make install. But we found that when you try to compile ClamAV, it's expecting to be run as a ClamAV user, which doesn't exist in Cloud Foundry, obviously. So you're actually going to try to get it to run as a system user. So we had to say, disable the ClamAV user and use this directory for where we're going to compile to, which the directory would be under home vcap app ClamAV. So at this point, it's running the compilation, and this run command runs at build time. So if you notice, it's after each run.
Don't point to the screen, doesn't help.
One command and each build is run. Thanks, Dirk. Thanks, Dirk.
I do it all the time.
You do.
So at this point, we're still in build mode. Now we're going to tell Docker one more thing. This last command here, run CVZF. What we do there, basically, we have now the binary image. Of course, we want to ship it outside of a Docker container. Remember, in the end, our Docker container is only an environment where we build this binary. We want to get this binary outside of the virtual file system that is Docker.
Right.
And we do that using the shared volume that Rami also already mentioned. But before we can do that, we need to first nicely package it up. So that's basically what this tar command, let's see if the mouse works now. This tar command down here does. And we exclude a bunch of admin directories that we don't need. That's what that -- exclude does.
So then the last part is obviously mounting the volume of the /shared and then copying the CMD command there. That's actually run when you actually execute this Docker image. And it says, go ahead and copy this built binary into the shared mount point.
The reason why that's the runtime command is that these shared volumes are only available at runtime and not at compile time. So or build time. We can build all the binary that we want at build time, but only at runtime can we copy it out of the container, because only at runtime do you have that shared volume available. Yep, so there it is. And then here's how you run everything. First, you do a build command. Docker build -- no cache basically is just a safeguard. You give it a name with a -- tag, and you say the current directory, which is why that // is there. So this will run, to jump back, this will all the run commands. It will not run the CMD command. It will only run the run command. So at this point, this is what takes a while. This is why you grab a beer. Because this make install step will take a while. It will untar the ClamAV, it will make install it, and will tar the binary back up for you. And then you run this second command, the docker run command.
So the docker run command basically says this volume $pwd, which is my current working directory, should be mounted under /shared, which is what we are saying is the mount point inside of our Docker container. And we're going to use the same tag that we built, ClamAV binary, as what the Docker container we're running. And again, it's only running the mounting of the shared volume and copying of a tar file out. So this is pretty close to instantaneous. Like all the other stuff is done in the docker build command.
You want to do this one?
Sure. One thing that kept coming up as we were building this and discussing this was, hey, you're running ClamAV in Docker, right? And we said, no, we are not running it in Docker. We're only using Docker to build it. When we were testing, we had the Docker container up and running, and we would SSH into it and play around with it. But when we deploy to PCF, we don't deploy through a Docker image. We deploy the tar file that we untar in Cloud Foundry and have our service leverage ClamAV.
By the way, we forgot to make a slide about that. We found some very, very nice thing there. There is a standard virus that all virus scanners will recognize. That is just a text file. So there is out there a fake virus. If you ever need to test that viruses are being recognized, a fake virus which says, I'm not a real virus, but all virus scanners in the world will recognize that as the test virus.
Test virus. ICAR virus.
Thank you.
EICAR.
You remember it?
I do.
Very good. So how do you get ClamAV ready to run into PCF? Well, first of all, we need to include the ClamAV binaries into your config file inside your deployable jar. You want to do that?
Then you use a script inside of your jar that, when the container starts up, will extract the tar file. So that's usually, it's a .profile.d that's in the top level of your built jar, and that contains a script. It's a directory that contains scripts, and it executes those scripts in Cloud Foundry when the container boots up. So on the right here, that's the script. So what it says is, that's my app directory. We had to load some libraries for ClamAV, wait for the container to start up, and then basically untar it, copy over our config file. And that's step 3.
Oh, did I get it right?
Well, step 3 was copy over the config file.
Sorry. And then, so how do you start it? Well, basically in our Java service that actually will receive all these requests with these files attached to them, we have a little run thing that's basically just run every time you start up a Java thing. You do that with this Pivotal Cloud annotation. And basically the post construct there basically just runs the ClamAV daemon. So that's the server, yeah. Otherwise, it doesn't work. Is the easy answer. We also thought about that. Every now and then, when you do it right away, it's not ready for some reason. We wanted to wait for something, but realized that sleep 2 always works, so we left it right there. If you have a better suggestion, so yeah, this will basically start up the daemon. So this, and then basically in our Java code, we can receive a file and pass it onto this onto a certain port where this ClamAV itself is running. In actual fact, it's a little more complicated than this. We have to start up 2 things.
Right.
Because Clam, well, maybe you tell them.
Well, Clam is just a scanner, and it relies on a virus database, right? So if you just try to start it the way it is written right now, your container won't start because it takes 5 to 10 minutes to download these virus definitions. So we've actually had some steps to download some virus definitions, tar them up and include those, and then we ran a command called freshclam, and what that does is it goes and updates the virus definitions periodically. So we haven't showed that as part of this slide deck, but that's also part of the requirements to get ClamAV up and running.
How do you monitor Clam? How do you make sure it doesn't go down?
We didn't do that because it was a POC.
But in real life, what we should do is run that MCAR virus scan on it like every 15 minutes or so. And that should, or I guess 2 files. One has, just a plain text file, and one has the fake virus in it.
And that's the beauty of Docker. If you had it running in Docker, it could crash and just restart it in Docker.
But that's the beauty of PCF. If it crashes, PCF will restart it. It's just the same. Yeah, but we did run some tests. So on what we didn't show you, that we actually did run in development ClamAV inside the Docker, and then we indeed ran those 2 test files to see that it was working correctly before we deployed it to the actual cloud.
Right.
And well, you guys have your various health checks, so I guess part of that could be to run it.
Right. So we could expose a health endpoint that would execute a check against ClamAV. Specifically, there's a ping command. So ClamAV provides a ping command where you send it the word ping and it responds with the word pong. And so if you get back the word pong, then ClamAV is still running.
That's an even better one. Yes.
Yeah.
So to sum it all up.
So we built a binary for PCF. It does require a very specific environment. Docker is a great way to give developers consistent development environments. Building the binary in Docker is the way to go. We tried building it manually. That was just too much of a pain. And Docker scripts aren't hard, and Dirk and I had a lot of fun writing this.
Absolutely. Any questions?
Michael.
It's not so bad.
Actually, I have a lot, but I'll start off with one.
You get one.
So,
what led you to move away from the build pack? Because the build pack, like, there's the C++ build pack, which is the community-supported one that would build the binary for you on the Linux. What led you to move away from that versus using a combination of Docker and the Gradle tasks to extract and everything? I don't believe it was available in our PCF environment. No, you'd have to write your own build pack. Then we didn't want to write our own build pack.
Yeah. No, you're right. In principle, you could totally do that. I think.
An issue of like how do you mix that into a Java application?
Yeah.
I was on a project where we combined .NET and Java into one build pack. So.
Whoa. We're obviously not as smart as you are. So. No,
it's a way to go, and the problem I've ran into is maintaining it simply. You'd have to, like, if you fork one, then you'd have to rebase all the time if you wanted to keep it up to date.
Yeah. So where this is much simpler and so far, because we talked about maintaining it a lot. The cool thing is that the clam binaries aren't updated that often. In fact, we don't want them to update regularly. We only wanted them to update it when somebody actually makes an action to now update clam. And that actually makes it easier here. Just redeploying it doesn't recompile clam from the source. It's only when you provide a new clam binary that everything will be updated. So it's a more controlled process this way. Yeah. Okay.
Did you put any thought into how you would update the service if there was a bug so that the client itself?
So if Clam had a bug, we would get the latest version of Clam. Presumably they'd fix that bug and rebuild the binary and do a redeploy.
Okay, so it would be like a manual process.
Yes. Yes.
And that was what I just said, referred to. That was intentional. We really wanted it to be, you have to actually do a step to redeploy a new binary, because that way we know we only get, binaries that are already, in Clam basically not fresh, but one down. So we know for sure this is stable, and we don't always follow the latest binary from Clam. We have to make a decision. Now you're right that could totally be updated, be automatized. That you have a script that says, do this whole Docker process all by itself. You can have Maven Docker plugins that make all of this more or less automatic. Or a bash script actually would do it, because it's basically just 2 Docker commands.
Yes, sir.
How do you keep the minus definition?
So we use FreshClam, and FreshClam is a pre-built utility that'll download the latest virus definitions. We run it as a daemon and say, go and do a check every hour.
Yeah.
Okay.
Yeah.
Like, are you going to make this into a real thing, or is this just going to stop?
Well, right now it's a post POC mode, so it runs the ClamAV solution. We've got a service that wraps it. We've got some health endpoints and the FreshClam updating. Doing some load testing against this, it was not able to handle a sustained load for more than about 10 to 20 minutes. So right now we're actually looking into potentially moving over to Symantec, but for compiling open source applications in Docker, this is pretty much the way to go for us.
I mean, could you potentially run, let's pretend you could run Docker in production and also safe to do it. You could run a bunch of different ClamAV images, containers, and then just talk to different ones and ask there get free, basically have a queue for all of the guys, right?
But you can do the same now, right?
Well, with PCF, what I'm talking about is really splitting the two processes. Because right now you're running through endpoint and your Clam scanner on the same blocks.
Yeah.
Correct.
About really 2 containers, and one is a front end that will basically talk to any of the available.
To have a pool of the ClamAV containers.
That's good for the resources. It's less good for the bandwidth, because of course then now the nice thing is that once the endpoint has the file, it just moves locally within the same PCF container. You don't have to then send it further along into PCF. And given that we're scanning reasonably sized files, so it's computing power versus internal network bandwidth.
Independently scaled front end to the back end. Like I would expect me to scale the back end, but I wouldn't see this to scale the front end independently of that. So especially since the front end is plugging in, that makes sense. Well, it's just you might end up, depending on how you do the distribution, if you do run rugged, you might end up with one, endpoint that's really busy with big files that they don't have to scan, and then now you have this one endpoint that's done. It's almost like you're more of a queuing, but I mean, queuing thing would be it's a proof of concept.
Right.
Yeah.
Dave.
Did you guys watch Dirk Janssen concourse talk in December?
Mm-hmm.
Nope.
So that's kind of what came to mind to me about like leveraging Docker as a tool in your pipeline to build things.
Right.
I think that's kind of like baked in natively to concourse.
Yeah.
For a lot
Nice.
of the same reasons of having like a controlled environment to provide
Yeah.
right? Nice.
No, that is true. This is similar in a certain way.
Is that on the website there?
That talk is on the website. Yes, I just checked it. Yeah, you're right. So there is a for people who can't hear this, there's definitely a similarity between how we've done it and how Concourse does it, which also uses Docker images to build intermediate steps. And you could move over to Concourse, but you guys are very happy with Jenkins, so there's no particular
For now,
reason
yes.
for that. But for now at least.
Yeah.
And again, I mean, to make this automatic, it requires a couple lines bash script. I mean, it shouldn't
Right.
be too hard to deploy this part. I mean, of course, if you don't go all the way of Concourse that way, but the essential compilation step should be very easy to mimic that way. Yeah.
So you mentioned that it was falling over after 2 minutes sustained load. Do you know what the limiting factor was?
We tried a few things. We tried creating a connection pool to ClamAV on the server itself because we thought we were just hammering it too much. And we ran it for that. Allowed us to go from about 5 to 7 minutes before it totally crashes to about 10 minutes. We're thinking now that we're just running out of the system sockets. At least that's the current theory. I have no way how to test that, no idea how I would test that. So we kind of said, forget this, we're going to go with Symantec. So this is in post-POC, and it's not currently under active development. It's kind of been stopped at that point.
If you went to Symantec, you'd still have the same architecture with like a Java front end.
Correct.
It's like other processes inside the same container, is that right?
Well, assuming Symantec has a solution where you could stream it to them, maybe you would just wrap that or just call them directly. Yeah. Yeah.
Have you tried it on a standalone machine, actually?
So locally, it works perfectly fine.
You can hammer it as much
And
as
you
you
can
want.
hammer it as much as you want. It's just once you deploy it into Cloud Foundry, it dies after 10 minutes. We should talk.
Okay, any more questions? Mike, you had a bunch more questions, you said.
They're all covered.
Wow.
It's a little bit.
Okay,
All right.
that's
Thank
it.
you.